Good afternoon, everyone, and thank you for attending today's Thirsty Thursday webinar. It is the last webinar of the year, and we're pleased to have Mike Burke with Sparklike here to educate us on preventing scratches and edge damage. Before we begin, just calling attention to some dates on your screen and on the following slides. NGA has two of its key in-person events coming up at the very beginning of the year. Its annual conference in La Jolla and the BEC, which is Building Envelope Contractors Conference in Nashville at the beginning of March. We hope you will visit glass.org to learn more about those events and ideally register. We'd love to see you there. In addition, due to annual conference scheduling, our first Thirsty Thursday of 2020 will occur in February on the 20th, and we'll have more information to share on that in the near future. In the meantime, though, I'm pleased to introduce Mike. Mike is the North America Technical Representative for Sparklike. He has worked in the technical and training areas of the insulating glass industry for over 25 years. Mike is the chair of the IGMA Glass Safety Awareness Council and has also served as a member of the Technical Services Committee. He has presented seminars and webinars for IGMA, Fenestration Canada, NGA, and for a variety of member companies. He is a regular guest columnist for DWM magazine and has written over 30 published articles and columns. Mike holds a master's degree in adult learning and development from Cleveland State University and a bachelor's degree in business from Myers College in Cleveland. Mike, I'll turn it over to you.
Thank you, Sarah. Hello to everybody. Thank you again for joining us today. We'll get through these first couple here that Sarah talked about. I want to talk a little bit about the damage to glass. You see so much of it when you're out in the field. Years back, I asked the owner of one production facility. It was a large facility. He had 3 tempering lines. He had a complete fleet of trucks. He had a large staff. And I asked him, what is your biggest operational expense? And I really thought he might say utilities due to the cost of the tempering furnaces. But he didn't hesitate. Quickly, he answered in one word. He said glass. And I was really surprised at that, because if you spend any time in these glass plants, you see how much glass comes and goes as it flows. And if you looked around, you've seen the dumpsters full of broken scrap glass, large amounts of broken scrap glass. Some of it's necessary. Some of that scrap is just due to optimization and customers' work to save as much glass as they can. But often it's damaged glass and glass that they couldn't use and glass that's thrown away because the operator may not have been trained. He may not understand what's acceptable, or he has the insufficient maintenance of the machineries. So there's a lot of reasons why these dumpsters are full, but it's kind of scary when you think you got your biggest expense is glass, and yet daily you're dumping large bins of glass as scrap. So we'll talk a little bit about the damage, what causes it, and maybe perhaps we can eliminate some of that. Now, to some of you listening, I'm sure a lot of this will just be common sense. You'll say, well, everybody knows that. To others, it may be new to you and it may help you. We'll talk about a couple types of damage, mainly preventing the scratching and edge damage. We'll talk about where it occurs. We don't have a lot of time in 25 minutes or so, but we'll talk about some diagnosis, some quality expectations, and some precautions that you might take. And hopefully you'll be able to use this as a starting point to help minimize the amount of glass you're throwing away or the amount of glass that you have to remake. Usually one or two things happens when people notice damaged glass. The operators will do one of two things. They'll either let it go and think that it's not really going to hurt anything, nobody will notice, or maybe they won't notice till it gets into their house, or maybe they don't care, but they'll just let it go on down the line. The other times, they'll see the damage, they'll replace it and throw it away and make a new one or make a remake, but they don't do anything to correct the problem. They don't do anything to try to stop future damage, or they don't look into the process at all to see what's causing the damage in the first place. So we'll look at those sources of damage, and we'll kind of step through the entire process from beginning to end, and they'll point out some areas where some of this damage occurs. Where does it occur? It occurs everywhere. Everywhere in the plant, you're going to see places where glass gets damaged, and the two causes are glass to glass and glass to metal. And if you look for those two things, anytime there's glass to glass, there's going to be damage, and anytime there's glass to metal, there's going to be damage. These pictures here, if you've ever been to the glass shows or some of the home and garden shows around your town, you'll see some of these firms that offer glass scratch repair kits or machinery to repair kits. These pictures came from the Vitrum Glass Show in Italy, and I walked up and I was talking to the operator of that display. You can see the black marks there where he puts the scratches, made some scratches by his fingers. And I wanted to know how he was making the scratches. I really pictured some big old metal tool that he was using to scratch the glass, to get those deep scratches. And if you look and see, it's just glass. He's got a piece of glass in his hand that he puts some tape around, and he uses that glass to scratch the other glass. Nothing fancy, nothing heavy, nothing pointed. It's just glass to glass. And you got to keep in mind, it doesn't have to be a big piece of glass. It could be a very small shard of glass that can cause the damage. These shards can be trapped in the carpet. They can be trapped in rollers, conveyors. They can be trapped in gloves. They can be trapped in wood, any kind of wood surface or any kind of wood area. All right, so they don't have to be very big. Same thing with glass to metal. When you see damage from glass to metal, even the smallest chip that you see, it's going to cause damage someday. Sarah, can you help that? Thank you. It's the season. So if you've got glass to metal, even very small glass chips, they will break in time. They may break on your production line. They may break in assembly. They may break if you're using an oven roll press. They may not break until you get to the glazing operations. They may not break until they get transported on a truck somewhere, or they may not break until a year or so down the road when due to thermal stress. That small glass to metal is enough to cause enough damage for that glass to run, for that glass to break. And keep in mind, when you don't take care of the scratches and damage early in the process, every step you take, you've added value to that product. And more and more expense is going to be in your warranty to replace it. So you want to get to your operators and let them know that they need to look all the time. It happens everywhere. It happens from the beginning when you store the glass. When it comes into your plant, depending upon how you take it out of the scotch packs or how you take it out of the crate and where you store it. Metal surfaces on storage racks, metal belts, storage straps with metal buckles, hooks that you use to tie the glass to the racks. Any place where there's glass to metal, you have the opportunity to even do the smallest amount of glass damage, and you want to take care of that. It's especially true if you've got cluttered or closed-in areas like this, where you might try to load a single light into one of these racks or take a light off the back, and you're squeezing through small spaces with a lot of metal around. Not only is it dangerous because a small bump to that glass could cause it to shear right now, but could also cause that glass to stay together further on down the road, and it won't break until, like I said in the previous slide. On the right is, you may recognize that's a bracket that's used by a lot of people to keep the glass in the free fall rack bases. If you look around your cutting area, you'll see glass racks on bases, and they'll use this device to hold the glass against the first light of glass against the pack so it doesn't fall. Obviously it's not strong enough to stop the whole glass pack from falling, but it's enough to keep the first light from falling as you move the stuff around. Again, if you move stuff, it should be strapped down. But this particular plant, every one of these braces, the the rubber protective coating had been removed. So on every one of them, this was glass to metal when it was holding up that front light. And I inspected them, and every one of the racks had damage right below that metal bracket. Now, that may be in the middle of a light. You don't know when it's cut where it's going to be, or it could be on the edge. But again, glass to metal will cause that damage. So in your storage areas, make sure all your racks are protected. If any glass is on them, on the bottoms, you can see here that down here you got rubber pads on the bottom, which is a good thing. Always watch for any kind of metal or any kind of glass to glass process in your process. Cutting. I talked about Worn surfaces, again, wood, where shards of glass can get trapped in the wood and scratch every light that comes across there. They just get embedded in the carpet. It can get trapped between the breakout edge here and the carpet. You can see in this case the amount of shards that are laying on this carpet. So you want to make sure that your tables are in good repair, your glass is clean. You don't ever want to use air hoses to clean it. Air hoses don't clean anything. They just embed the shards deeper into the carpet or deeper into the wood, or in some cases send them over to the other department. But you want to make sure your carpet's in good shape and you want to clean it. Yeah, I understand that it eats up vacuum cleaners like crazy when you suck up glass. Buy some cheap vacuum cleaners, replace them often, and make sure you keep that carpet very clean. And you want to watch for operators who move with the glass or drag glass. So you get the glass to the breakout table, they may start to move the glass without the airflow, on. And so again, all these shards in the carpet will cause scratches into the glass. You want to look for impact damage. A lot of times when the breakout people are ready to go, before they've cleared the breakout table, they'll hit the button and start to transfer the next light onto the breakout table. And you'll often see glass to glass damage. Or even when they break the lights apart and they're kind of sitting there floating while they store them, you'll get ready to sort them, you'll see them bump into each other. You have to stop that. That's glass to glass damage, and that will impact the units or the glass further on down the road. So again, any place where you might see some glass to metal, any place you might see some wood, exposed wood that would have some shards, you want to make sure that that gets repaired. Breakout and sorting. Now these are the same people that just cut the glass and they broke it out on the table. You want to watch for pancaking. We call it the top right. And those are very small lights of glass there, but they'll take them and snap them off and stack them up. And you'll have glass to glass scratches. Now, there's Lucor on there. There's interleaving powder that will prevent some of that, but you don't really ever want them to stack glass like that and carry it away somewhere. You're going to end up with damage. You don't want the operators to carry more than one light at a time. Again, I know they're in a hurry. They got to keep up. So often they'll take a light in each hand and they'll walk over and try to slide it into the harp racks or the slot sorting racks. If the slot sorting racks aren't just about perfect, the glass won't slide in there very easily, and they'll end up rocking it in. When you rock it in, you end up with scratches on the adjacent lights, often like a swoosh mark. You'll see that leading corner on the bottom will touch the light next to it and cause a curved scratch into the glass. You want to make sure that the bottom, the slots are always cleaned out so that as they slide them in there, they don't contact existing glass. In most places you go, you will see broken glass in the bottom of those carts. It makes it difficult and unsafe to slide the glass into the cart, but it also damages the glass that's there. Again, you got glass to glass. You put that in there and then you're going to roll it across the floor to some other process. That's going to put edge damage on every one of those lights. You want to watch for storage areas. You want to watch areas where you're storing the glass prior to the washer so that if you have glass that's hanging out, that you haven't done any damage there, that it doesn't get damaged or scratched while it's hanging out. You want to look here to the types of divisions you have between the slot sorting racks. Make sure they're clean. Some are worn real bad, some are one solid piece. In this case of the picture on the lower left, they're individual things that spin, which is fine as long as they're clean. All right, but if they're not clean, you need to make sure that they are clean. And I would really recommend you clean the racks every time before you start loading them. When they come back from the washer, take them either to another area or somewhere. No air hoses, but sweep them out, inspect the slots to make they're clean. The other issue with slot sorting that I see a lot of is this front edge here. If you look here, a lot of times that front edge is not protected, and they will chip or damage the bottom of the glass every time they load a light, no matter what the size. The other one you'll see sometimes is this top metal edge at the back. And when you have extremely large units like you do here, you'll see damage if it hits that bar. So you want to make sure you have something to stop them from hitting that bar. You never want to put them in there at an angle so they're resting against that metal bar unless it's protected. I saw one plant where I went to, it had a complete harp rack full of large glass. Every one of them had a chip right along that bar. And again, it doesn't have to be a very big chip before it's going to run. Got to go fast here. Edge deletion. Depending on your process, depending on how you're edge deleting, this is just another opportunity to pick up and handle the light. You can scratch it as you take it out of the rack or put it back in the rack after you're done. Again, the edge deletion machines have a lot of exposed metal. On the bottom right, we have a seaming machine where we're going to go in and we're going to seam the glass. Again, there's a lot of areas there where we can have glass to metal, and you want to watch that. Up in the top view, you'll see a lot of the rollers and casters. These rollers and casters get filled up with dust, dirt, the coating, the coating material that you're deleting, and they don't turn, they don't spin. And so as you slide the glass across there, you put a lot of scratches in there. You don't ever want to touch the top of the coated glass. This is soft coat glass, that's why we're deleting it. And you see in this picture, this guy has his gloves right in the middle of that low E coating. His gloves are going to be full with grit and contaminants no matter what he does. So he's going to contaminate, he's going to scratch that glass. He should only handle it from the edge. And the other thing I try to tell edge deletion people when they're doing it manually, slow down. You know, you'll see a lot of rounded corners for quality issues. But if you go too fast, you end up driving the glass into these rolls or into some metal object where you're doing more damage. Take your time loading, unloading, and just slow down. It does a great place for a lot of damaged glass. Then onto the washer loader. Again, we're going to pick it up. We're going to take this piece of glass and we're going to pick it up again. We're going to take it out of a slot sorting rack where we can do damage, and we're going to load it onto a washer entry conveyor. In this case here on the left, there's a washer where that first entry roll is supposed to free spin. The purpose of that roll spinning is to allow the operator to load the glass easily and not having it drive along and scratch the glass. In this case, the operator thought he needed to adapt the machine so it was spinning. You want to watch for any kind of adaptation for machines, because obviously the manufacturer didn't intend that. But you want to watch that the washer loader doesn't hold the light against a moving roll. If they don't do it here, they'll do it to achieve spacing. They'll be looking at the assemblers on the other side of the washer who was ever receiving glass, and they'll hold on to the back edge of the glass while the other wheels continue to spin against the glass. So you want to make sure they don't do that. You keep it suspended from the conveyor until it's ready to enter the washer. This washer on the right, even the one on the left, all of that shininess, all of those scratches are all glass to metal. That's all glass that has caused those scratches, that shininess. The floating, if your washer has donuts or something like that, you got to make sure they're there and in the right shape. Because again, every time this guy loaded a light into that and hit that metal, he's damaged the edge of the glass, and that glass will break in time. One of the biggest causes of damage. You want to make sure too that he doesn't go faster than the assemblers. You don't ever want to stop the glass in the washer with the brushes running, especially with low E coatings. If the glass stops and the brushes are still spinning, you're going to see a cloudy scratch area on the glass once it comes out the other side. You want to look for damage. You want to make sure if you've got a thicker glass that things are adjusted right, and you're not hitting the air knives or something else in the washer. You want to also be sure that you never use another light of glass to clear a light of glass that's stuck in the washer. Oftentimes a light will get stuck and they'll just throw another light in behind it, or maybe 2 or 3 lights behind it before they realize there's nothing coming out the other end. All this glass is breaking and getting stuck into the compression rolls and will scratch glass for a very long time after you finally stop the process and try to clean it up. So make sure your operators understand if it's not going out the other end, don't keep loading it. Call maintenance, open it up, and don't try to force it through with another light. In some cases, I've seen large pieces of plexiglass and things where they try to force it out, but that's not going to take away the broken pieces of glass. You're still going to end up with glass-to-glass damage. Watch for orientation. You want to make sure when the glass exits the washer, it's in the same orientation that it entered the washer. If it's rotating or spinning inside the washer, something's not adjusted right. Perhaps your brushes aren't adjusted right, or they're worn real bad, and now the glass is starting to spin inside the washer. It's going to cause, again, more scratches and more damage. In the assembly area, this top right picture, They had 3 lights of glass in the washer and they went to lunch. And nobody cared. And they kind of finally came out of the washer after they were on their way to the lunchroom. All 3 of these glasses have been damaged, either with the front leading edge or they've scratched the one at the bottom. So again, you don't ever want to make sure, you want to make sure they never contacts the other glass and never runs into each other. Depending upon your assembly and your process, you want to watch metal tooling, application tools, cutting things, any kind of metal tools you might have in the assembly area. You want to be very, really careful with those. Down the bottom, I didn't show the top of this person, but this person was more interested in their cell phone over here, sitting to their right, than they were about the glass exiting the washer. You always want to make sure that you're aware that it's coming through and make sure that it doesn't contact the light ahead of it. You also want to be careful so that when the operators pick up the glass, the trailing edge doesn't bend down and touch the metal portions. A lot of times they'll reach over. They can't wait for the glass to get there. They'll reach over and drag it towards themselves. And when they do, they damage the trailing edge. When they lift the front edge, the back edge hits the metal. Same kind of things when they're done with whatever they're doing. When they want to send the unit to the next process, a lot of them think they're curling on ice and they shove, or playing hockey. They shove the unit as fast as they can across the next conveyor. In this case, if the rolls are not turning, or if the glass is going faster than the rolls themselves, you'll do a lot of damage to the glass. So again, in this area, always look for glass to metal, always look for glass to glass. Unloading, another area. Again, we're going to handle glass, we're going to handle big IG units here. And you want to make sure that if it's a large light, that the operator can handle it, and it might take 2. And if you're not waiting, or if the glass isn't removed from the exit conveyor, the next unit or the next light coming through will damage it. You want to always be sure that there's no impact damage on the exit. And it's this place I see a lot of that. Big units you'll store on A racks or L racks or something like that. Again, lots of opportunity for damage to the bottom, because the bottom of the racks are not clean or not protected against damage to the glass. And they look for strapping and that kind of stuff. The pictures I have there, these are IG unit carts that I saw at one facility. And their intention was really good. They decided they would put this rubber matting down in the bottom of all their IG unit carts. Well, each one of these little areas here, and the slots in the areas, contained many shards of glass. And that wasn't the worst part. The worst part were the metal screws they used to hold the rubber onto the mat. And you can see the damage caused to the rubber mat as the units were slid in and out. The same kind of damage occurred. Every unit that I saw that I took out that was next to one of these screws had edge damage. So you want to make sure with your IG unit carts, as much as any other thing in your facility, that they're clean, there's no metal to glass, and no glass to glass, because that's where the damage is coming from. Same thing here with the wood slats. If there's shards of glass, broken glass, they're going to scratch your glass every time you lower them. All right, and you'll see that mark. Just, again, watch how they do that. Watch the speed. Watch how they're doing that. But most effectively, especially watch for the metal screws and things like that. Glazing, shipping, and delivery. So now we're going to ship it off to the next place. It may be in your plant for glazing. It may go on to a pack like the left here. Make sure that it's stored tight and secure. It's not going to slide around and get the kind of damage you see here. Make sure it's not going to slide out. If you're loading it on your glass trucks, make sure there's, again, no glass to metal. Make sure that it's secure. It's not going to slide around on you once it goes down the road, because you're going to scratch it. If it goes to your glazing department, look at their tools and equipment. Look at their tables. Are their tables clean of debris and things? You know, it doesn't always hit the glass, but look at their tooling. Is the tooling worn? Does the tooling have shards of glass in it? This one on the bottom right, that's actually a hammer I took away from a guy who was glazing units with it. And he actually would just lay the flat part of this mallet on the glass and bang the glazing strip in with it. And there were shards of glass embedded in this wood. And he destroyed every unit he made. And I stole it. I took it with me. I have it as a permanent souvenir. But look at those areas again: glazing, shipping, and delivery. Always making sure that the glass is secure, no glass to metal contact, and it's not going to move around on you. Some diagnosis. Work upstream. If you detect a scratch on a glass, depending on where you find it, you want to start to look upstream. If you find it at the assembly area, Maybe it's in the washer, or maybe it's all the way back in the cutting area. But you need to start working upstream until you find the location. Prior to the washer, it's going to be difficult to see the scratches because they're covered with interleaving powder or Lucor. The glass is dirty, but you need to clean some units and make sure the scratches aren't there before the washer. And you need to continue all the way back through edge deletion, through cutting, breakout, all the way back to storage to try to find out where that damage is coming from. Don't just let it go because it's not going to go away. If you got scratches that are repeated every so often, you see the same scratch in the same location, measure that repeat. Often you'll find that measurement of that repeat is the same as the circumference of one of your rolls. And you can narrow it down to say something stuck in one of your rolls. So every time that roller came around, it scratched that glass in the same place. If they're parallel scratches, again, measure the distance between the scratches and the edge of the glass and go back up through your process until you find where that's coming from. Circular scratches are usually from orientation. I talked about if the glass comes out of a system and it's not in the same orientation it went in, that means it's spun inside there. Look for that. Look for circular scratches. Cloudy scratches, a lot of times from brushes or from being stuck in the washer with the conveyor not moving, but something like glass brushes are running up against it, constantly making that damage. Last but not least, edge damage. That's pretty easy to see. And if you've spent any time in any kind of glass processing plant, you've seen it. You've seen these chips, you've seen the damage, and you let it go. You can't let it go. It's going to come back. And that leads me to the next slide. Well, not quite yet. Look at your quality and warranty policy. Define the viewing area. Most quality policies have a viewing area where they say 80% of the viewing area is what I'm concerned about. Scratches in this area can only be this big, because scratches outside of this area can be a little bigger. Define that and set expectations for your customers. Define the viewing distance. We have a lady that called up and says, I see the scratch when the sun comes up. And every morning she would come out when the sun was lined up with it at a certain distance and point out to the scratch, even to the point where the field service guy had to come when the sun came up to look at that scratch. So define viewing distance, define a viewing area, determine the background light, and review your warranty. Make sure customers understand that this is normal and this is standard. This little scratch in the corner that this lady sees is not reason to reject the window. You can't just get perfectly clear glass all the time. You're going to have some scratches, some small ones, but define those, put them in your warranty. Make sure that you know the difference between impact damage and stress crack damage, and look at all those kind of things. I have this slide up as we're out of time here. I always use this about beating a dead horse. I usually talk about it in industry meetings where we tend to beat a dead horse for a long time. But I would ask you, in the case of glass scratches and damage, beat the dead horse. Don't give up until you find the problem. If you have impact damage, don't beat the system until you find out what's causing it. Orientation things should be easy to sign. Cleaning and vacuum. Don't stop demanding clean areas. Don't blow the dirt and the contamination into another department. Don't sweep when you're running production, and keep the place clean. Train your staff. Maybe this webinar will help. It's a little short, but maybe it'll help. Another thing to keep in mind is measure your scrap glass. Clean glass scrap. I hope you're recycling it and sending it to be used as cullet for new glass, but measure it. Maybe every time you dump the dumpster, or measure it once a week, but get a handle on how much glass you're scrapping and try to find out why. Again, it's the most expensive product you have coming in the door. So try to measure that scrap glass. And finally, field failure analysis. Get your service team, when they find an issue in the field, to bring that unit back. Don't just throw it away. Bring it back and let your quality people and let your production people look at it. Do some forensic analysis and try to decide where the damage came from, where the scratches came from. But there's a lot of value in evaluating those things. And I really crammed a lot into 30 minutes. There's a lot more that we could talk about. We could stretch this topic into a couple hours without any trouble. I hope that's enough to get your curiosity up. You'll head out to your production floor and look for some of those issues. If you have any questions for me, feel free to give me an email on my address there below. Thank you very much. Sarah?
Great, thank you, Mike. If we do have just a minute for questions, if you want to use the chat box, that is an option for you. Otherwise, we've recorded this webinar and we'll be posting it on glass.org in the near future for your later reference. We otherwise look forward to seeing you at NGA's future events, whether that's annual conference, BEC conference, or our Thirsty Thursday webinar on February 20th. With that, we'll sign off and wish everybody a very happy holidays. Thank you, Mike.
Thanks. Thanks, everyone. Sarah, you still there?